Running a bunch of Kubernetes clusters gets expensive fast. It's a drain on your budget and your ops team. But on the other hand, sharing one big cluster safely, that's really hard. So in this explainer, we're going to break down exactly what vCluster is. You'll get why it's such a big deal and how it works as this awesome cheat code in real-world Kubernetes setups. You're watching AI Tech Cheat Code, where complex tech becomes simple. All right, let's dive in and see how this thing actually works.
So here's what we're covering. First, we'll get into the whole multi-tenancy dilemma. You know, the problem every KX team runs into. Then, we'll introduce virtual clusters as the solution and really get into the nitty-gritty of how they work. After that, we'll check out some real-world use cases, I'll show you a few common beginner mistakes to avoid, and then we'll wrap it all up with the key takeaways.
Okay, let's get right into it. To really get why something like vCluster even exists, you have to understand this core problem that platform engineering teams fight with literally every single day. It's this constant battle, this tug-of-war between two big things. On one side, you need super strong, secure isolation between your teams. On the other, you've got this immense pressure to keep your costs down.
In this right here, this lays out the two old-school ways of dealing with it. And honestly, neither one is great. On the left, you've got separate physical clusters. This is the private island approach. It gives you perfect isolation, right? Every team gets their own control plane, their own API server. It's awesome for security. But the cost? It's huge. And your operations team? They're totally swamped managing all these different clusters. Now on the right, you've got the cheap route. Just stick everyone into shared namespaces on one big cluster. It saves a ton of money up front, but man, it's chaos. Everyone's sharing the same control plane, so the walls between teams are paper thin. And that leads to some major headaches.
So let's really dig into why just using namespaces isn't enough. First off, everyone shares one API server. So what happens when one team pushes a bad script? It can bog down the API server for everybody. Total mess. Then you get these nightmare CRD conflicts. Imagine your data science team needs version 1.5 of an operator, but the web team needs version 2.0. Well, too bad. In a shared cluster, you can only have one, so someone has to give in and a project gets stuck. And on top of that, developers don't get real admin access. They can't install their own tools like service meshes because it would affect the whole cluster. This turns your platform team into a huge bottleneck, and everything slows down. It's a classic case of trying to save money, but actually losing way more in wasted time and frustration.
So you're stuck with this awful choice, right? Expensive isolation or cheap chaos. What do you do? Well, a new idea came along that promised to give you the best of both worlds. The rock-solid isolation of separate clusters, but with the awesome cost savings of a shared one. And that's where virtual clusters come in.
So, what exactly is a virtual cluster, or vCluster? Okay, at its heart, it is a 100% real, certified Kubernetes cluster. That certified part is super important. It means all your tools, kubectl, Helm, whatever, they just work. No changes needed. But here's the crazy part, the magic trick. It doesn't run on its own set of machines. Instead, it runs as a little self-contained app inside a normal namespace on a bigger host cluster. Each vCluster gets its own totally separate API server and control plane. You get that amazing isolation, but without the giant bill for extra hardware.
This diagram is the perfect way to picture it. You've got your big host cluster on the outside. That's what provides the real muscle, the CPU and memory. Then, inside one of its namespaces, you just deploy vCluster. It spins up its own tiny control plane, usually using something lightweight and fast like K3s. This is why it's so efficient. And for the developers using it, they connect to the vCluster, and to them, it looks and feels exactly like their own private Kubernetes cluster. They have no clue they're just a tenant on a much bigger system.
And hey, this is not some weird experimental thing. This concept is totally battle-tested. We're talking over 40 million deployments. It's trusted by huge companies, Adobe, CoreWeave, NVIDIA, to solve their biggest multi-tenancy problems, especially in really demanding areas like AI and GPU workloads, where you need both isolation and efficiency.
Okay, so we know what a vCluster is and why it's so useful, but how does it actually work? How does it pull off this cluster inside a cluster trick? Let's peel back the curtain and look at the mechanics.
You know, the whole process is actually pretty simple and clever. It all kicks off when you run a command like vCluster create. First thing, it just creates a normal Kubernetes namespace on the host cluster. This is going to be the home for your vCluster. Then, inside that namespace, it deploys a single stateful set. Why a stateful set? Because the control plane needs a stable network name and storage.
Now, this stateful set is the real heart of the vCluster. It has two really important containers inside. The first one runs the control plane itself, that lightweight K3s instance with its own API server. The second container runs a special piece of software called the syncer. And this is where the real magic happens.
Okay, check this out, because this right here is the absolute core of the vCluster cheat code. The syncer is smart. It doesn't just copy everything. Higher-level things like your deployments, your stateful sets, and especially your CRDs, those exist only inside the virtual cluster's brain, its API server. They never even touch the host cluster. That's how you can have two teams using different versions of the same operator without any conflict. But when a deployment inside that vCluster says, hey, I need to create a pod, that's when the syncer wakes up. It grabs the pod definition, tweaks it a little bit so it doesn't cause any trouble on the host, and then creates a real pod in the host cluster's namespace. The same thing happens for services, persistent volume claims, the actual physical stuff. So think about it. You get this perfect virtual bubble for all your configurations, preventing any conflicts, while you're still efficiently sharing the real expensive resources like CPU and memory underneath. It's brilliant. This is where most Kubernetes setups get tricky, and understanding what's virtual versus what's physical is the absolute key to making vCluster work for you. If this is making sense so far, give the video a quick like. We're about to dive into why this matters in the real world.
All right, we've got the how down, so now let's talk about the why. Where does this actually make a huge difference? Let's look at the best use cases where vCluster is a total game changer.
Okay, use case number one, and it's a huge one, developer self-service. Just imagine this. A new developer starts, and instead of waiting days for a ticket to be processed, they run one command and boom! They have their own admin-level Kubernetes cluster in less than a minute. That's a massive productivity boost. Another killer use case is in your CI/CD pipelines. For every single pull request, you can spin up a fresh, perfectly clean vCluster. You can run complex integration tests, database migrations, anything, and then just tear it down. No more tests interfering with each other. For companies that host multiple customers, vCluster is the gold standard for multi-tenancy. You can pack hundreds of clients onto shared hardware and know for sure that they can't mess with each other's stuff. And of course, the big one, cost savings. We've seen companies take hundreds of small, inefficient dev clusters and merge them into just a few big host clusters, cutting their cloud bills by an insane amount, like 70% or even more.
Now, vCluster is super powerful, but that extra layer of magic can sometimes trip people up when they're starting out. So let's go over the most common mistakes so you can sidestep them completely.
And this question right here is probably the number one thing that confuses new users. You connect to your shiny new vCluster, you deploy your app with kubectl apply, everything looks perfect. Then you switch your context back to the main host cluster, you type kubectl get deployments, and it's empty. Your deployment is gone. It's confusing at first, but this is actually vCluster working exactly the way it's supposed to.
So let's break down the top 3 mistakes to avoid. Number 1, and this is the big one, treating a vCluster like it's just a namespace. It's not. It has its own brain, its own API server. Your deployment object lives inside the virtual API, not the hosts. You have to be talking to the vCluster to see it. The second mistake comes right from that first one, not understanding how the syncer works. Your monitoring tools that are pointed at the host cluster, they won't see your deployment. Why? Because it's a virtual thing. It never got synced. But they will see the pods that the deployment created. You just have to adjust how you think about observability a little bit. And finally, this is a huge one for the platform admins. Forgetting to set resource limits. A vCluster is still just an app running in a namespace. If you don't put regular Kubernetes resource quotas on that namespace, one out-of-control vCluster could suck up all the CPU and memory and bring down the whole host. You have to put those guardrails in place, always.
All right, we have covered a ton of ground here, from the big multi-tenancy problem to how vCluster actually works and what to watch out for. So let's boil all of that down into a quick cheat sheet to make sure it all sticks.
So here's what you need to remember. vCluster gives you real, honest-to-goodness Kubernetes clusters, but they live inside a simple namespace. This gives you that amazing API isolation, just like having separate machines, but without all the cost and headaches. It means every team gets their own little kingdom, their own control plane, so they can stop fighting over CRD versions and permissions. And because they're all sharing the same underlying host, you save a ton of money and your servers actually get used efficiently. Bottom line, vCluster just makes Kubernetes multi-tenancy way, way simpler. In the next video, we'll compare vCluster with namespaces and separate clusters, doing a full head-to-head breakdown. If you like this content and you learned something from us, please subscribe to this channel for more updates like this video and share this video on all your social networks.